Welcome to Lesson 2 Chemistry, and this is Form 1. The topic is detecting acids and alkalis. Remember, we are discussing acids and alkalis. Here are the things we use to detect acids. For example, we have litmus paper as the first thing we use to detect acid, and the second one is litmus solution, and the third one is pH scale, and lastly is pH meter. So we are going to look these things into detail. So let's begin with the history of detecting acids and alkalis. So this was developed by this man called Robert Bose. This was an Irish scientist who detected acids and alkalis. So he tested acids and alkalis with the plant juice from red cabbage. We have a cabbage which is red, and he squeezed this red cabbage to get the juice, and that juice was used to detect acids and alkalis. So in his experiment, he found that when acid is added to red cabbage juice, it turns from purple to red, and when an alkalis is added, it turns from purple to green. And also he discovered that juices from violets turned purple when acids and with acid, and greenish yellow with alkalis. A change in color in litmus. This is also another thing that he discovered. He discovered that a litmus could change the color when dipped in acid or a base or an alkalis. So what is this litmus? It is a juice from lichen. There is another plant called lichen. So when that plant is crushed, the juice is called the litmus, and it is a purple dye. So let's begin with the litmus paper and litmus solution. So the litmus paper, as I have earlier on said, that the litmus, it is just a purple dye which comes from a plant called lichen. So starting with litmus paper, so litmus paper solution is absorbed onto a paper strip to make this litmus paper. So you have this litmus solution which is being absorbed, or which is absorbed onto a paper strip to make this litmus paper that we use to detect acid and bases. So how do we test for acid? So here is the thing. The litmus paper you use to test for acid should be blue, and here is the diagram. Let's see, it is a shape which is showing or which is representing the litmus paper, which is blue. And when this paper is dipped into an acid, it turns red. So when this paper is dipped into an acid, it turns red. So when you see this change in color, just know that that substance is what is an acid. Now testing for alkalis. The litmus paper should be red. If it is red and dipped in an alkalis, the color changes to blue. So which is the opposite of testing an acid. Remember, for testing acids we use a litmus paper which is blue, and for alkalis we use a litmus paper which is what? Red. So on litmus solution, Remember, litmus solution is paper. So how do we use it to test for acids? It turns red when it comes in contact with acid, or in short, if you take two drops of litmus solution and you add them in an acid solution, you are going to see the solution changing from paper to red. And if you are testing for Alkalis, you expect the color change to be from purple to this color, which is blue. So I hope you can now differentiate the colors in terms of testing for acid when we use litmus paper and also litmus solution. And also there is another similarity in terms of the color changes, because the colors, for example, the final color when you are testing for an acid is red, and also the final color when you are testing for Aquarius is blue, which is the same as when you are using a litmus paper. So let's proceed. Let's talk about indicators. So there are over 20 indicators that are used to test for acids. These indicators are coming under the pH meter. Not pH meter, but pH scale. So when you are using a pH scale, you also use these indicators. So mostly used indicators are, we have methyl orange, phenolphthalein, and universal indicator. Universal indicator is whereby there are so many indicators added together to come up with this indicator. You can use it to test acids or Alkalis. So methyl orange is pink in acid and yellow in alkaline solution. And phenolphthalein is chorus in acid and pink in alkaline solution. So this is the alkaline solution and it is pink in acid. No, it is pink in alkaline solution but chorus in acid. Universal indicator, it has different colors in acids like red, yellow, and orange, and blue or purple in alkaline solutions. So this is the pH scale, which starts from 0 up to 14. So there are numbers between 0 and 14, which are 1, 2, 3 up to 14, and they are different colors. So the colors you see, like if it is red, it means that one is an acid from battery, which is a very strong acid. And we have the final color, which is a bit purple, and last but one is blue, right? So let's see how this pH scale was developed. The man who developed this is this man, a Danish scientist. So he did that to compare the strength of acids and bases. So these acids, for example, from 0 to less than 7 shows acid, and from greater than 7 to 14, those are alkalis, and 7 shows a neutral substance. And then we have this 0 which is the strongest acid, and 14 as the strongest base. So this is just to show the pH of different substances that we use in each and every day. For example, we have this sodium hydroxide we use in the lab, and the pH is 14. And at the bottom we have the acid, butyric acid, which is whose pH is 0, and that one is the strongest acid. And we have the milk we consume each and every day. So this is the milk. Its pH is 6, so it is slightly acid. And also we have tomato juice, whose pH is 4. And again we have the vinegar, whose pH is 3. Is a bit one of the strong acids. And also we have lemon juice, whose pH is this. So which means the lemon juice is one of the strongest acids that we consume each and every day. So this is also another substance that we use each and every day, and this is toothpaste. So the toothpaste has the pH of this, which is what, 9. So this is your work. You need to compare these solutions with the colors on this pH meter and find out their pH. I can give you an example, like this one, the first one. This, you see, it is matching with this color. So I can see the pH of this substance is 1. So this one is a strong acid. So you do the same with the remaining acids. These are not, let me say, get me clear on this. Oh, these are not acids. You do the same with the remaining substances. Alright. When you are done, you will send in form of a text, or you just take a picture so that I can see or I can check your answers. So that marks the end of our lesson. Thank you very much. Have a nice day.